Here's our official start clock, so you have 10 more minutes. 1 more minute. Great, it's time. So we're gonna go ahead and grade it in class like we've been doing. And again, as a reminder, so there's only 5 problems this time, so each problem is worth 2 points instead of 1. And whatever your score is on this quiz, if it's higher than one of your previous quizzes, then you can replace the lowest of your previous quizzes with this quiz. So the first problem, I think, is the hardest, just because there's the most going on and it's easy to lose track of what's going on. So we'll just step through this real quick. And again, it's just, this one here is mainly practicing, just keeping track of all this stuff that's going on. So we have this list. Again, my convention, 2 S's means it's a list of a list, double plural. Total starts off as 0. The 4 XS in XSS, so this XS is going to be going over each one of these lists. The very first time it's this top list over here. And so for J in range 2, 3, 4, this is maybe another, I don't know, slightly tricky-ish thing right here. But so we start at the 2, go up to, and not including the 3, step size of 4, doesn't matter because we're just gonna skip it each time. So each time we'll just be adding the second entry because it starts at 2, and we're going adding the second entry, index 2. So first time it was the 2, then it was the 6, and then next time it'll be the 2 again. Do all that, and we get total equals 10 for the first problem. Number 2. So here we have our string and a list of strings. And the key idea on this problem, again, is that if you're comparing things and they're of different types, then they can't possibly be equal. They can only be equal if they're the same type. And in this case, the S of -1 and the XS at -1 both refer to this 5 at the end over here. They both happen to be strings, and they both happen to be the string of 5, so they are equal to each other. The condition here right though is asking, are they not equal to each other? So we get false because they're equal to each other, it means they're not equal to each other. And so we get the false. So number 3 are, again, just order of operations, making sure that you can track all of this. So the first thing that we'll do is that 6 raised to the 0 power, anything to the 0 power, just 1. And then 1% 2 is going to be 1. And then times 3 is 3. So it'll be 3 plus 1 plus 3 for 7. Number 4, so we have our for loop. This for loop here is going backwards. We're starting at 2, going to -2, and a step size of -1. So we'll go in a descending order. And then what the if statement right here is asking is if our index is truthy. So if the I value, I is a number, so if it's anything other than 0, then we'll do the thing inside of here. But when I equals 0, we'll skip the stuff inside of here. So stepping through that, I equals 1, go inside, I equals 0. So we don't go inside when I equals 0. Then we'll do the -1, I equals -1, but we don't do the -2 because we always go up to, not including this. So our total is equal to 3. And the last problem, number 5. So here, just a range, and the numbers, anytime you have numbers in Python, anywhere they are, you can specify them using any of the number formats you want. So here I've just done all 3 binary. This one is the equivalent of 1 decimal. This is 2 decimal. This is 1 decimal. And so it's like range 1, 2, 1. So it's I will be equal to 1. It'll never be equal to 2 because we go up to, not including this number. So we just print out total equals -1. Again, each problem's worth 2 points. So total up your your score, put it on the top out front, and then pass them up. Are there any other quizzes? Okay, so we had a couple of questions about the quiz. So let's just answer those real quick. So here we had a question about exactly what is going on right here. And so this s at -1 and this xs at -1, they're both equal to 5. In order to illustrate this, I'm just going to go into interactive Python. I think that'll be the easier way to do that right now. And so there's our s and our xs, so s at -1, xs at -1. And the key thing here is because this is a not equals, that's the same as, so s at -1 not equals xs at -1 is the same as not xs at -1 equals xs at -1. And so since this thing right here is true, then when we negate it, we get false. Yeah, so I guess pronunciation-wise, some people pronounce this bang equals, exclamation equals, not equals. All of those are valid things, but the key is just that it negates, it does the opposite of what equals would do. Does that answer the question? Question is, if this is your worst quiz, what's going to happen to your grade? None of your other grades will be lowered, but this one's still going to be entered in as whatever it was. Yep.
Can you explain how this is different from problem 2?
So the question is, how is this different than the last quiz? And it's just this not equals here that.
Right. So, but when it was, because on the practice quiz it said it had the double equals, and the result was false.
Can I see what the practice quiz looks like?
Oh, okay, never mind. I understand.
Okay.
Sorry.
Yeah. Right.
I would also kind of understand, but also kind of have that question. I think that the difference has to do with like the colon in the practice quiz after the one, but I'm forgetting exactly what.
Yeah. So the another one of the tricky things that you have to pay attention to with these sort of problems is what happens with the colon versus the not colon. So here, this is when you have the square brackets but no colon, we just call that indexing. When you have the colon, we call that slicing. And if we have, so s, when we slice s, so I'll say like 1 to 3 like this, a slice of s gives us a string back. And an index of a string also gives us a string back. So slice and index of a string gives a string. But when we have a list like this, xs, and we do an index, we no longer get a list back. We get whatever happened to be at this position. But when we do a slice, same one I did before like this, a slice, even if this slice only gives us one element, it still is guaranteed to be inside of a list. So slice of a list is always a list. And something like this, a list with just the one element that's the 2 inside of it is never equal to just the element itself. Yeah, so a lot of subtle things to pay attention to. All good questions so far. Any other questions about this or anything else about the quiz? Okay. Then we're going to, today, so we'll finally actually talk about the files like I've been promising for a couple of days now. And our motivation for what we're sort of building up to is in Python, there's this thing called matplotlib, which is how you can plot pretty graphics. And so we'll be reading in data and then plotting graphics this week. That's what we're trying to do. Our Jackie Chan picture here is maybe this is how you feel from this homework assignment. Again, the homework, if you're collaborating, is due on Tuesday. So today, office hours will be your last chance to get help from me about the assignment. But then there's the TA times both today and tomorrow that you can use as well. Before we actually get started on the files today, though, I just wanted to talk about some other news that you probably didn't see over the weekend. But since last time we were talking about how just for small sums of money, people betray their country and divulge secrets to foreign countries, and that can cost the US billions of dollars. So just yesterday, somebody was arrested who worked at the Naval Reactors, which is the organization in charge of all the nuclear submarines in the US Navy. And he was arrested for selling all of the nuclear secrets to foreign countries. And his price tag was $10,000 to do that. $10,000. So this doesn't speculate as to his exact motive. I'm sure that will come out through the court process. This is just a notification that he's been arrested and he's charged with accepting $10,000 from France, actually, in order to give them all of the secrets to our nuclear submarines. Okay, so files. There's here we go. There's a number of things that we're going to be talking about today. And 2 things to keep handy are, again, your Python cheat sheets. So this bottom left corner over here, and this is on the 2nd page. This is what we'll be talking about today. And then there's a couple of concepts that aren't actually on this cheat sheet. And so I've created a little cheat sheet here, which I call the minimal required knowledge for this section right here. And you can take a look at this if you want. You can print it out if it's helpful for you. I didn't give you a printed copy because there's not going to be quiz material on this. So this will just be something for you to reference while you're working on your next homework assignment or the lab for this week. But those are the 2 sort of references, like cheat sheet sort of references. And then again, this all comes from chapter 9 in the book and these 2 videos from Corey Schaefer. So the first thing that we have to talk about is a little bit about how this terminal works in more detail. So let me just clear this up again. And so up here, I have an empty file, monday_section1.py, and let's just add a print hello world, so it does something, and I press this triangle button. And so we've seen this a bunch so far. You press the triangle button, it spits out a whole bunch of stuff down here, and I've said that for some of us, we can just type Python 3, and then the name of our file like this, and it will work. And for some of us, you have to type out this big long thing. So we'll start by talking about like exactly why is that the case? Why is there this difference between this big long thing and just the file name itself? The answer is that this big long thing up here is what we call an absolute path in computer science. So I'll just copy and paste that whole thing right here. That is an absolute path. And a path in computer science is just a reference to a file. It's the location on your computer that the file exists. And an absolute path is a reference to a file that works anywhere, no matter what folder you currently have open. An absolute path is a path that works anywhere. It always references the same file no matter where you are located. And so that's why when you press the triangle button up here, VS Code always puts in the absolute path right here because it knows that this is always going to work. And so both of these two things actually are absolute paths. This is the absolute path to your Python installation, wherever that happened to be installed at. And this is the absolute path to the file that you have opened up here that you're trying to run. You know, let's see, so looking at this, I know it's an absolute path because it starts with a slash. An absolute path, let me switch over here to this cheat sheet right here. An absolute path on a Windows machine, so I'm not on a Windows machine, but if you are on a Windows machine, it would always start with a C:/ or a D or an E, whatever your drive letter is. And on everything else, so whether it's Mac, a phone, anything that's not a Windows machine, it always starts with a slash. So this is an example of an absolute path on from a Mac computer, and this is an example of an absolute path from a Windows computer. This right here is what's called a relative path. And this is a relative path because it does not start with a slash or does not start with a C:/. So a relative path is a reference to a file that is not an absolute path. So whatever the rule for your system about what an absolute path looks like, whether it's the C:/ or starting with a slash, a relative path is any path that doesn't look like that. And what the computer does in order to access anything that's using a relative path, the computer always converts relative paths into absolute paths to access a file. And so how does it do that? There's a certain what's called a system variable on your computer called the working directory. The working directory is like where you are located on your current computer. And on the terminal, and this is true for both Windows and Mac, you can find your working directory with the pwd command down here in the terminal. pwd stands for print working directory. And directory is the same thing as a folder. Anytime somebody says directory, it means folder. Anytime somebody says folder, it means directory. There's no difference between the two. This one's just a little bit older of a term. And so this is my current working directory. And you'll notice that this right here matches the very beginning of this absolute path up here. And so yours is going to be slightly different than mine, but they'll probably almost match each other. So here I have, starts at /home, ends at week 6, starts at /home, ends at week 6. And so whenever I type in just a file name by itself, so a relative path to a file, a path that does not start with a slash, then the way that the computer or the terminal or Python, anywhere we're working with files, the way it converts the relative path into an absolute path is we put the working directory at the beginning of the relative path to make an absolute path. So when I typed Monday section1.py up here and everything worked, it's because my working directory, which I see using the pwd command, gives me this right here. And so it creates the file by just doing Python 3, copy and paste this right here, adds a slash to separate that folder from this file right here, and it works. If my working directory was something different, then I would have to type in this entire thing. But because my working directory is this week 6 right here, I don't have to type in that whole thing. So for those of you who've been having to type in this entire thing, the reason for that is because your working directory has not been the location where you've saved your files. Any questions so far?
What does the CD do?
Good question. So the question is, there's this command cd, which I've talked to a couple of you about, and that's what we're going to talk about next. Cd stands for change your working directory. Cd equals change working directory. So it's a little bit confusing because in pwd, they have the W for the working, and then in cd, there's no W, but it still changes the same thing. And so that's how you can change your working directory. If I wanted to make my working directory be this thing right here, I can do cd and then copy this. So I'm going up a level to my CS40 folder, and I'm no longer in my week 6 folder. I type pwd, I'm in CS40 right here, not in my week 6. And so now if I type Python 3, Monday underscore section1.py, I get this error message saying it can't open the file, no such file or directory. The reason for that is because it's looking in the pwd folder, and it's not located in the pwd folder, it's located in my week 6 folder. In order to go back to my week 6 folder, I can do cd week 6 like this. Now typing pwd, it has the week 6 right here. So now if I copy and paste this command, which didn't work before because the working directory was different, but now I copy and paste it and it does work because the working directory is the location of the file. So pwd print working directory, cd change your working directory, and yeah, both of those sort of work together. They affect each other. Good questions. Any other questions so far?
Is there any way to like nest these commands if you have like very many nested files? Can you keep adding commands to like keep going through the files to find an individual one?
Yeah. So questions about like nesting these commands and making it so that you can find files a little bit easier. And there's a couple of tricks that we're going to see next. The first one is there's this special folder called .. So first I'm going to type pwd. Here's my working directory right here. And now I'm going to do cd space .. This .. is a special folder, which means go up one level. So cd .. pwd. And you can see that it removed the week 6 right here from my working directory. So this cd .. was this, gave me the same result as when I did this cd big long thing to this big folder. And so it's potentially more convenient. And this cd .. it'll do different things depending on where I'm located. So that took me out of my CS40 folder down into my project folder. So I'll go back into CMC 040 like this. And one of the things that you can do when you're cding is you don't have to just specify one folder at a time. So I can do CMC-CSCI040 / week 6 like this to go first into this one and then into this one, sort of chaining these two folders together. And it just appends both of those onto my working directory at the same time. Similarly, so I'm going to go back to my CS40 here, type pwd. I can, if I didn't want to, for whatever reason, actually change my working directory into this week 6 folder, I could do Python 3 week 6 / Monday_section1 to have this file run. But remember that the way that we convert a relative path into an absolute path, so this up here is an example of a relative path because it does not start with a slash and it does not start with a C:. We can convert this relative path into an absolute path by just taking our working directory and putting the path at the end of it. So this is the same, because I'm in this folder right here, it's the same as this right here when I'm in this folder right here. So anytime you have a relative path, it depends on what your working directory is, where you're going to access it. In VS Code, the default working directory that you start with is whatever over here when you do this open folder, that's going to give you what your starting working directory is. So here, if I'm opening up CS40, opening up CS40. I don't know why you're not opening anything. Maybe because I have a different VS Code open. But, well, what was supposed to happen is that it would load it up, and then it would, I'd type pwd, and my working directory would be CS40. So I don't know why VS Code's not doing that, but that's how you set the default working directory for your VS Code. And then I always make my default working directory my folder that contains the entire course, and then I have all my week folders, and so I'll cd into the week folder to start working with the files in that week folder. Are there any questions about relative versus absolute paths or working directories? Okay, so then what we're going to do next is we're going to, inside of Python, we're going to open up, start opening up files. And we'll see that this discussion of working directory and relative versus absolute paths is going to be crucial for opening files inside of Python. So in order to open a file in Python, it's pretty straightforward. Move up here to the top to do it. The syntax is with open and then path to file as F. And then I'm just going to write some stuff right here and like that. So this line right here is taken just from your Python cheat sheet. So I'll quickly switch over to that. It's the very top line right here of your Python cheat sheet, or down here in the bottom right corner is the full version of it, with open as F, with open as F, and then a colon. Inside of here is what you're doing with the file, and then in this case, I'm reading the contents of the file, storing it into a variable, and then just printing out the contents. What goes in this string right here is a path, either a relative path or an absolute path to your file. So currently I'm in my week 6 folder. Down here I type pwd, you can see I'm in my week 6 folder. So inside of week 6, I'm going to create a new file. I'll just call it blurb. And inside of blurb, I'll put the, this is the blurb, and save that in my blurb file. Over here, under open, I'm going to change that to blurb. And it'll open up the blurb file, which I just created, read the contents of that, stick it into the text variable, and then print out those contents. So let's save this over here, down here, rerun this, Python 3, Monday, section 1, and it prints out this is the blurb. Again, what's happening, blurb right here is the path to the file. The path is, or I called the file name blurb, and so that's what I put right here. Read means get all of the contents of the file. So this is the contents of the file. This is the blurb. Put it into this variable text, and then we're printing out that variable text, and so we get this is the blurb down here. Okay.
Is blurb, is it a Python file?
Good question. So the question is blurb a Python file? And the answer is no. That blurb, this blurb file is just arbitrary file, just contains some characters inside of it. I could create a Python file and open it up. So if we come down here, week 6, right-click, new file, and we'll call this new Python file .py. Since it ends in .py, it will be a Python file. And then over here, I can say something like print, this is the new Python file. Save new Python file.py. Down here in the terminal, I can run new Python file.py, python3 space new Python file.py. I hit enter, and you see it prints out this is the new Python file. But if I here, if I load up new Python file.py like this and print it out, it's going to actually print the contents of the file. It's not going to run the file. That this is just a file that contains characters. This is just a file that contains characters. When we do the f.read, all it does is pull out the characters from that file, stick it into this variable text, and then print them out. So there's nothing special about this file over here about how it's getting read or anything. It's just contains some characters inside of it. Good question. Any other questions so far?
So as long as they're under the same folder, you can just use the open function.
Yeah, so the question is here, so both these files, blurb and new Python file, they're in the same folder as my actual file right here, the Mondays_section1.py. And so because of that, I can just use the name of the file right here. But what if they weren't in the same folder? Then what would happen? And so remember that this is a relative path right here. So the way that Python converts this relative path into an actual file name is it figures out what is your working directory, which you get by pwd, appends this or prepends this to whatever you have up here, and that's the absolute path to your file. We'll see some variations on this now. Let's create a new folder. I'll call this folder data. And then inside of the data folder, we'll create another file called blurb. So I have 2 blurb files now, a blurb file in week 6 and a blurb file in data. My blurb file in data, I know it's in data in VS Code up here because it has week 6, then data, then blurb. This one right here, it's just week 6, then blurb. So that's how I can tell the difference between these 2 files and which ones they're located in. Right up here, it shows me where they're located. And this one, I'll say this file is in the data folder and save that. Now under here, under Monday_section1, I'll rerun this. And you'll see that, and let's change this back to blurb, like that, save that, down here, rerun it. It says this is the blurb because this blurb file right here refers to the blurb file that's in my working directory, that's in my week 6 folder. It refers to this one right here because this is in the week 6 folder. This one right here is in the data folder. In order to get access to the one in the data folder, I need to somehow change this path so that it references the one in the data folder. One way of doing that is putting data / like this. Now when I rerun this, you can see we get this file is in the data folder because it's doing the one that's in the data folder. I could also specify an absolute path instead of a relative path. So my working directory, pwd, for me happens to be this big thing right here. For you, it's going to be something different. And I could take this, copy and paste it right here, add that / to separate them, save this, and now rerun this. and it says this is the file in the data folder still. So you can always specify either a relative path or an absolute path in the same location.
What will happen if, let's say I jump back one directory?
Yep.
It's the same file under a different directory, but it's the child folders.
So,
Two same ones.
yep. So the question now is a slightly more complicated variation of what we've been seeing so far. So here, I'm going to go back to what we have here, a relative path data / blurb like this. This relative path data / blurb. And I'm going to change my working directory so that my working directory is this right here. Anytime we have a relative path, anytime that we have a relative path, the way Python converts that into an absolute path is it takes your working directory, whatever the working directory happens to be when you call Python, and appends that to what's up here. In this case, now if I type Python 3 Monday_section1.py, this does not work. Python says there's no such file or directory because there is no Monday section1.py in this folder right here. In order to get to it, I have to go inside of the week 6 folder like this, week 6 / Monday_section1.py. This will run fine from Python's perspective. So notice that there's 2 different error messages here, although they look similar. This error message down here says no such file or directory data / blurb. This error message up here says no, can't open the file Monday section1.py. So this error message here meant that we couldn't find the file that we were actually trying to run with Python. This one here means that we've run Python successfully. It's successfully running this, this file right here. But when it hits this relative path, the way it converts this relative path into an absolute path is it prepends your working directory, puts this at the very beginning of it. And there is no file at this location right here. There is no file at this location because if we look over here, looking at my folders, I don't have a data folder inside of my CS40 folder. I'm going to save this again real quick, save it up here, rerun this command down here, rerun it, and we still get the same error message, but now it's with the absolute path instead of the relative path. In order to make this work, I would have to change this so that the absolute path references the week_06 because that's where it's actually located. This path up here does exist, so I'll save that, come down here, rerun it, and now it works. Now it's able to actually find it. When we're using an absolute path up here, it doesn't matter what my working directory is. I will always be able to find it. So here, my working directory is this in my CS40 folder, and it works. I go into my week 6 folder, I run the program, and it works. Doesn't matter what my working directory is, it will always work with an absolute path. But when I had the relative path, it did matter what my working directory is, and it will only sometimes work whenever the working directory is set correctly.
Is the slash in different directions still absolute path?
Question is, so here, these are called forward slashes that I'm using up here to separate all of these folders from each other. And in every computer made within the last 10 years, you can always use forward slashes to separate folders from each other. On Windows computers, older Windows computers, instead of using forward slashes, they use backslashes to separate directories. And so on older Windows computers, you have to use backslashes. On modern Windows computers, you're allowed to use either a backslash or a forward slash. It doesn't matter. On anything other than Windows, you must always use a forward slash. Your questions? Any other questions so far? Okay, I think So my experience with students is that students tend to find, when somebody's explaining the difference between absolute paths and relative paths, everything makes sense. But as soon as you are like actually confronted with it, working on problems that require you to sort of figure out what the current paths are and navigate between them, then you suddenly realize that nothing makes sense at all. And that's okay. That's very likely to happen to many of you on this week's lab. But the key thing to remember is what is your current working directory and how does that relate to all of your files? You always convert a relative path to an absolute path. I have this written out in our cheat sheets somewhere. You always convert a relative path to an absolute path by prepending whatever your working directory is. We've seen, so this pwd command from the terminal to get your working directory. We've seen this cd command. Let's take a look at these two commands next. So this is how you can get the current working directory from within Python. So it's not only a terminal thing, but you can do print, import os, and then print, where are you going? There you go. os.getCwd. GetCwd gets your current working directory in Python, and so that is equivalent to the pwd command. You won't have to use this on any of your assignments, but if you look at the through the textbook or watch those videos by Corey Schaefer, he uses these quite a bit. So the getCwd command returns a string, which is your working directory. And so it gives you the same result as the pwd command in the terminal. Up here, when I run this program up here, it's just printing out the result of getCwd, which is getting your current working directory, which for me right now is this, and that gives me the same exact result as pwd. I personally find using pwd in the terminal much easier than trying to create a whole separate Python program and running this. Question is, what does OS stand for? It stands for operating system. There's just a handful of functions inside of here which are specifically for dealing with various aspects of sort of low-level things about your computer. So like your working directory. There's a number of other things inside of here, things that like programmers maybe need to have access to, but like your average user doesn't necessarily need to understand. Good questions. Any other questions so far?
Just wondering, what is the OS operating system? But if it is, why do you have to import OS?
So the question is, why do you have to import OS? And it's just what you have to do in Python. Just like if you wanted to have access to math things, you have to do import math and then math.square root.
What does OS represent? Just operating system?
So OS is just a library in Python that has certain functions inside of it, like this getCwd function, in the same way that math is a library that just has functions inside of it, like square root. The functions inside of OS happen to be relatively low-level programming functions, but it's yeah. If you read the textbook on this chapter 9, they'll have a number of different functions that they use, but he references this one quite a bit all over the place because you always have to know what your working directory is anytime you're working with files. Okay, so that's the first principle working with files. Know your working directory. And now we're ready for our second principle. Know your file encoding. So this is going to be touching back now on all of the things that we were talking about with Unicode. And so I'm going to comment out these things right here and go back to just printing out the contents of our blurb file like this. This file is in the data folder. And on this open command, you can specify explicitly what the encoding is of your file using encoding equals, and then whatever you're going to put right over here. On your cheat sheet, they show you how to do this. At the top right here, they have encoding equals and then UTF-8 as just an example of a different encoding. But here's a couple of other encodings that you could use down here. If you are on a Mac, then UTF-8 is the default. So on a Mac, these two lines are the same on a Mac. These two lines are the same on a Mac. Let's go ahead and put that whole thing inside of a comment so that we'll be able to keep it. And keep that here so the things still run. If you're on Windows, the default encoding depends on many different factors. So if you're on Windows, the default encoding may be UTF-8, but probably it's not going to be, and probably it's going to be something else. The reason Windows has this varying default encoding is because it's more business-oriented, more enterprisey, and so they wanted to be able to attract, say, Chinese customers and advertise that we're going to use your disk space more efficiently by using UTF-16 for Chinese customers instead of UTF-8. And if you're in Greece, then it'll be using a default encoding that's better for Greek characters and so on. So for Windows, the default encoding depends on many factors. For Mac, Mac just wants to make things as consistent and easy to use between different Macs, so it always uses UTF-8 for everything. This is one of the major reasons why there's a lot of potential incompatibility between Mac systems and Windows systems, that if you are opening and saving files in Python and not specifying an encoding, then it's going to use whatever the system default is, which will be different on a Mac versus Windows, and so you'll get errors when you try to interoperate between those two systems. So for this class, and really always, if you use the open function, you must specify the encoding. If you don't, you're very likely to have weird errors that are going to be hard to debug. So I'm going to save that real quick and come down here and rerun our file again. And you can see that when I have my encoding equals UTF-8 right here, then everything continues to work just as it did before. VS Code, by default, is going to save things into a UTF-8 encoding. If I come over here to my blurb file, it says this file is in the data folder, so this is the one that we're currently looking at. And if you look down here in the bottom right-hand corner, it shows the encoding of this file, UTF-8. I can change the encoding of this file, save it in something different by clicking on it. And then up here, it brings me this menu where I can reopen with a different encoding or save it with a different encoding. I'll choose save it with a different encoding. And now here's lots of different encodings that I have to pick from. We'll just do this UTF-16 LE for a second. And you can see that now there's this looks exactly the same when we're looking at the file in here. The only difference is down here in the bottom right. If you're paying very close attention, you'll notice that this now says UTF-16, whereas it used to say UTF-8. If we switch over to any of my other files, you'll see that it says UTF-8 down here, because that's VS Code's default encoding. UTF-16, because I just went through the effort of clicking on this button, coming over here, save with encoding, clicking on the UTF-16. That's how you can change it. Everything else is UTF-8 because I haven't gone through that process. Everything else UTF-8. So come over here, I'll save this file now, come down here, rerun this, and you'll see that I get this error message because, so it says Unicode decode error, because my encoding, I'm trying to load it with UTF-8, but it's actually UTF-16 that I saved it with. And so anytime you have this mismatch of what you're loading it with right here and what you saved it with in the other location, you're likely to get an error message like this. Let's change this to, so if I try UTF-16 like that, down here, rerun it, now it's successfully able to open this file. So principle number one, again, you can get error messages when your path is incorrect. So we'll make our path incorrect by just saying, we'll do a file that doesn't even exist at all, like that. So that doesn't exist. When I run this, I get this file not found error. That file not found error can mean many things, but somehow it means that this path doesn't exist anywhere. You can also have your encoding specified incorrectly. So now if we'll do data/blurb, change this to UTF-8, have my encoding specified incorrectly, I get Unicode decode error. So file not found error means there's something wrong with your path. Unicode decode error means there's something wrong with your encoding. Unfortunately, though, it's not quite that simple because here, remember, data/blurb refers to this blurb right here, this UTF-16 encoded blurb. There's another blurb, though, that's in a different location, which is UTF-8 encoded. And so if I change this, removing data right here, removing this data, so it's accessing blurb. This blurb now refers to this UTF-8 blurb instead of the UTF-16 blurb. And so I run this, and so it says UTF-8, everything worked. UTF-16, it didn't work. Oops. Any questions about any of that so far? So the two error messages for file not found and your encodings not matching, not being correct. See, quick show of hands, how many people this all 100% made perfect sense? Okay, that's okay. What about this? Seemed like probably made sense. You'll have to play around with it, but I think you'll get there. Maybe half the class-ish. Yeah, so all this stuff that we're talking about today, the way it's going to come up in this class is your next homework assignment, and the labs are going to be using this. It's not going to be something that's on a quiz ever, though, just because there's so many like different things that are interacting with each other, and yeah, so this is for labs and homeworks, not for quizzes. Charlie?
Can you go across different encodings if you're writing instead of reading a function or a file?
Yeah, that's a good question. So the question is essentially, how do you move between encodings, like maybe converting between encodings? That somehow VS Code was able to convert between the encodings, that down here we had this option to sort of change the encoding of our file. We started with UTF-8, then we went to UTF-16. Let's now go to an Arabic encoding. Actually, we'll go back to UTF-8 and come down here, and so data/blurb and UTF-8 right here, save this. We can load it like this. Now what if we wanted to create a new file that had the UTF-16 encoding? The open function by default is only for reading information from files. If I want to write information to files, then I have to do something a little bit differently. Here I'll do with open, I'll call data/blurb_new, and then encoding equals UTF-16 as F. So it's, here's our old encoding, here's our new encoding, old file, new file. And in order to make this something that I can actually write to, I have to put a W like this. If we look at the cheat sheet, it has this information in our cheat sheet right here. Here's our file name. This parameter right here is optional. The default is R for just reading. I've changed it to W now so that I can write to the file. And then this encoding is also, it's technically optional, but something that you'll always want to have. And now I can do f.write text like this. So write will take this string right here as input and output it to this file F right here. F is going to be this file right here, and it'll use this encoding right here because that's what I've specified. I'm going to save this. Down over here on the left-hand column of my VS Code, notice that in the data folder, there's only the blurb file right now. When I rerun this command, because blurb new does not exist, it will create a new file with that name, and then it will have this content inside of it. Let's go ahead and run this right now. And if we look now inside the data folder, it's created this blurb_new. I can open that. And if I look down here in the bottom right corner, it has UTF-16 as its encoding. So it is possible in Python to convert between encodings using a technique similar to this. Did that answer your question? Good question. Any other questions so far? Okay, so when we were talking about Unicode, we said that there's this string type in Python, and that's the vast majority of times what we're going to be working with. But then there was also this bytes type, and we saw this bytes type as we were encoding and decoding things into the bytes type. And down here inside of the interactive Python, you'll recall that anything that's inside of quotation marks is a string, but if I put a B inside of, at the very front of those quotation marks, then it's a byte type. And a B, say of any particular letter, is never equal to that same letter as a string, because even though it has the same content inside of here, the type is different. This type over here is a byte, this type over here is a string. And this is confusing because there's also this R of A, that is in fact equal to regular A, because R, this is not a different type, this is just a different way of formatting strings. The B is a different type, B gives us the bytes, R gives us a different way of formatting strings. And R stands for raw, exactly. And the way that it formats strings is it ignores the backslashes. So here, \t is not a tab, it's just a actual backslash. This does not have the R out in front, so \\/ is how we represent a backslash, and then the test. And this is all review from what we talked about on strings before. The reason we're talking about this now is we're going to see how opening files relates to these binary and string types. In our our mode over here. So we have the read and the write. There's also these B, X, T, plus a whole bunch of other things as well. We're going to look at this B and this T next. The difference between B and T for our mode, which is this second parameter to this open function right here. If I were to open something in a B mode, what that means is that I'm opening it in bytes. So down here, I'm going, let's see. Let's comment out these lines for a second. And let's do with open data slash blurb, comma, B as F, and then text equals F dot read like this. Down here in my terminal, I'm going to open up interactive Python. So Python 3, and I'm going to open up this file up here. So -I, Monday, section1.py. And so BR is my mode up here. And I want to look at this text variable down here, text. And you can see that it has a B out in front of this this string because this is a bytes. If we have a B inside of our mode string, then we get bytes out. If we have a T inside of our mode string, we're going to get just a string out. So mode contains a B, get a bytes. Mode contains a T, get a string. And whenever you use this T mode, what's happening is that you're first opening it. So with open data slash blurb, you're first opening it in the B mode like this. And it'll give you something like byte equals F dot read. And then it's automatically calling the encoding conversion for you. It's saying text equals byte.decode UTF-8, or whatever the default encoding is for your particular system. These two lines right here are exactly the same as these two lines right here. So you might see these bytes come up in the textbook and in different places, but really the whole reason for our discussion about encoding and decoding with bytes is just to understand that it's happening behind the scenes automatically for us when we open in text mode, and it's automatically going to do the conversion for us, decoding or encoding, giving us the string that we want back as our end results. Are there any questions about that? So these two lines are, or not two lines, but two, call them paragraphs, are exactly the same. R stands for read. So here, the R stands for read. The alternative would be W for write. Again, the two main things to take away from class today: knowing your working directory. Anytime you're opening files, you have to know what your working directory is to know what file is going to get opened. And then principle number 2, know your file encoding. In this class, it'll be 90% of the time it's safe to specify encoding equals UTF-8 like this. But sometimes you might have to specify it as something else if it is a different encoding. That's it for today. Next time, again, we'll talk about, now that we know how to load data up, we'll talk about how to print out some data that we've loaded up and get pretty graphs, and we'll see what your next homework assignment will be to do that. I'll have my office hours right now. Happy to answer any questions about this or about your upcoming homework or anything else. But otherwise, I'll see you all on Wednesday.
Well, this is lab, we do still on Sunday night.